Hi everyone. Welcome to the Learn Ethical Hacking with AI, CEH v13 complete course. Today, in part 5 of Footprinting and Reconnaissance, we'll learn about network footprinting and email footprinting. Disclaimer: this video is made for educational purposes only. We do not encourage or promote any illegal activity. First, we'll start by looking at Traceroute. The main purpose of Traceroute is to find the path that data packets take from your computer to a target on the internet, like Google.com, and to measure the time taken at each step. You can think of it like using Google Maps to see the route from your house to a place 5 kilometers away, how many turns, hops, there are, how long it takes at each turn, and whether there's any traffic, network issues, along the way. If Traceroute isn't installed on your system, you can install it by running this command: sudo apt install Traceroute. Before installing any tool, make sure to update your system first. The time it takes to install any tool depends on your internet speed. To run Traceroute, just type the Traceroute command followed by your target domain name. If we run the command traceroute google.com, you'll see something like this with asterisks. That means the first hop your local network's router or gateway is showing up. But for the next steps, it only shows asterisks, which means no response is coming back from those hops. Seeing asterisks in your Traceroute output is completely normal. It doesn't mean there's a problem with your network. The main reasons for this could be security policies, ICMP rate limiting, or sometimes network congestion. Your internet connection is still fully active. To use Traceroute properly, make sure you run it with root permission. Or you can simply add sudo at the beginning of your command and then run it. If we run the command again with traceroute igoogle.com, which uses ICMP, here's what happens. Hop 1 your local router responds correctly. Hops 2 to 9 all you see are asterisk asterisk asterisk. That means these intermediate routers are not sending ICMP replies. ISPs or backbone providers often drop ICMP TTL exceeded packets for security reasons. Hop 10 this is Google's server or a CDN node. The RTT is about 32 milliseconds, which means it's a nearby Google point of presence. And in the output, this server is the final destination. If we run the command traceroute tp80 google.com, here's what happens. First hop, 192.168.247.2, this is your local gateway or router. Second hop, IP internal DNS hostname, this is Google's Edge server, which is located in your nearest region. After that, nothing else shows up because Google is smart enough to reply directly from the nearest server. That's why you don't see the full path all the way to the USA. When we run the command traceroute tp443 google.com, the traffic goes to one of Google's Edge or CDN servers, and its name gets resolved in the output. With this command traceroute tp443m20q3 google.com, you're tracing up to 20 hops over HTTPS, port 443, sending 3 probe packets per hop. In the output, you can see that the traffic goes directly from your ISP to the Google Edge node in your region. Traceroute for Linux, Ubuntu, Parrot OS, macOS, Tracert on Windows, shows how many hops, or routers and network devices, your computer has to pass through to reach a server like Google's, and how much time each hop takes. Traceroute can trace up to 30 hops. Hop 1 this is your local router, with a time of less than 1 millisecond since it's right next to you. Hop 2 and 3 these are inside your ISP's internal network. Hop 4 the latency increases a little here. Hop 5 1 probe, asterisk, failed, meaning there was no response at that moment, but the other 2 replies came through. From this point, you start seeing public IP addresses, which means the traffic is now being forwarded toward Google. Hop 6 your traffic has already entered Google's network. Hop 7 and 8 these are Google's backbone routers, where the latency is stable. Hop 9 this is Google's Edge server, or data center node, where your connection finally lands. You can also run Traceroute using the NetscanTools Pro tool. With NetscanTools Pro, you can do a lot of other tasks more easily too. Don't worry, we'll go through all of them step by step as we move forward.
If you enjoyed this video, don't forget to subscribe and stay with us. In the next part, we'll explore how to do OSINT on a target domain or company. Thanks for watching.